Good day, everybody. This is Mr. Kimpton. I'm going to talk to you about effects on climate, specifically how it affects temperature and precipitation of any given climate. This will cover targets 11 of the unit. Target 11 is define climate, short and sweet. Target 12 is describe and explain the factors that affect climate temperature. And then target 13 is pretty much the same thing, but how it affects climate precipitation, or how much moisture it gets. There's a good picture right down here below that you'll probably want to get familiar with for this unit and also later on this year when we study seasons. All right, so here we go. I would copy down the following questions below and answer them. So there's three questions that you need to know. What are the two main factors that affect climate? What factors affect temperature of a climate? And then what factors affect precipitation of a climate? So the way these grids we've set up for you work is that obviously they're the certain number of lines that you need, and then we're expecting that you can explain in that larger part. So, but don't just list the factors, also explain them. It doesn't say that in the question, but you should do it. All right, so let's talk about this. So the climate of a region is affected by four main factors. Specifically, temperature is affected by these four things: latitude, altitude, distance from large bodies of water, and then the ocean currents. So let's take a look at those effects on climate temperature. Latitude, that's just how many degrees above or below the equator you are, the equator being 0 degrees. In general, areas near the equator have warmer climates than areas far from the equator. And this picture does a good job of that. So 0 degrees to 23.5, north and south, Tropic of Cancer, Tropic of Capricorn, that's considered your tropical zone. It's not as nice and neat as this picture shows, but that's kind of how we teach it because it does fluctuate seasonally, drifts above and below these lines. So it's never quite that perfect. The sun's rays hit Earth's surface more directly at the equator than at the poles. At the poles, the same amount of solar radiation is spread over a large area, which brings less warmth. So you could have the same amount of light, but because it's at a different angle, it's going to be spread out. So if you ever took a flashlight before, and we'll do this in class, if you shine it directly 90 degrees down at the table, you're going to get a nice circular intense spot of light. However, if you angle it, the more you angle it down at the table or any surface, that light spreads out. It diffuses so that it's less intense because it's covering a wider angle or area of space. So you can think of it like that. Plus, it's even more enhanced because we live on a giant ball or sphere. So the effect is even more amplified. So the second thing on temperature is altitude. So here, right from your book, there's a great example, Mount Chimborazo in Ecuador. That's like almost right on the equator. I think it's like 1 degree south, something like that. And here's a map that shows you, okay, so here's the equator, and here's our elevation in meters. And it's obviously tropical down here in Ecuador. However, you go up into what is the northern Andes, and you can get into very different climates the higher you go up. There's actually glaciers on Mount Chimborazo. They're quickly melting, but they've been there for thousands of years. So in case of high mountains, altitude is more important as a climate factor than altitude. Another thing that affects the temperature is how close are you to large bodies of water. And then the fourth thing would be, okay, considering how close you are or far away from a large body of water, and if it's an ocean or a sea, what is the current? Is it warm or cold? So your distance from large bodies of water, that greatly moderates. The closer you are, it moderates your climate. It makes it less extreme. The temperatures nearby, because of that water, compared to being in the middle of a continent, are going to be moderated. Those ocean currents, so for instance, if you're, here in California or Washington, Oregon, there's something called the California current, and that's known for being a cool current. It's coming back down from the very North Pacific. Okay, whereas if you're here in Florida and the Gulf of Mexico and the Caribbean, you're getting a pretty warm surface current, and even the northeastern United States is known for getting pretty warm, particularly in the summer, because that's a warm surface current. It brings lots of warm air and moisture. That's going to affect the climate um, compared to as if it were to have a cold ocean current nearby. All right, we live here in Minnesota and we're not that greatly affected by ocean currents. They do affect us, but there's a lot of land between us and the Pacific or Atlantic Ocean, and our weather and climate changes quite a bit between when those air masses come onto our continent and by the time they get to us. So we're not directly related. All right, the next thing is three factors affecting the precipitation of a climate. And these will be, some of this will be a little bit of review, and then some of this will be new. The first thing is prevailing winds, which we've talked quite a bit about. Mountain ranges, as you can see here in this picture, you can probably figure it out, but we'll talk specifically. And then seasonal winds, which are very interesting. They're also called monsoons, which we'll talk about in just a little bit. So here we have our prevailing winds. We've talked a lot about. I like this picture because it shows the kind of the temperate regions and the tropical regions and the polar regions and your highs and lows and the way that things bend and flow. So prevailing winds move air masses. We'll study those quite a bit next unit when we do specifics of weather. Air masses are either warm or cool, dry or humid. And these huge prevailing winds that are made by the pressure belts that you've already studied, these blow across the surface of the earth, both land and water, and help to move these air masses. Depending on the air masses that are being moved, because of those winds, those greatly impact climate. So the amount of water vapor in an air mass influences how much rain or snow might fall. So if you're constantly having prevailing winds that are blowing off of the center of a continent where it's probably drier as compared to an ocean, your climate's probably going to be pretty dry. Whereas if you have a prevailing wind that's blowing off of a warm, moist ocean, you're going to most likely have more moisture in your climate or precipitation because of that air mass and where it's coming from. And remember, we always name winds based on where they're coming from because that gives us good information of what to expect that they'll bring. It's because of those air masses that they're blowing, those air masses being warm or cool, dry or humid. So the next factor for precipitation is a very cool effect. It's called the orographic effect or rain shadow. We'll just call it mountain ranges. That's going to be a lot easier to remember. But you have, for instance, like the Cascade Mountains are a good example of this on the west coast of the United States, Washington, Oregon, Northern California, actually all the way up to like British Columbia. But the prevailing winds, so we have the southwesterlies that blow off of the Pacific Ocean, and that air is going to be more humid and have moisture in it. However, air is not going to go through a mountain. It has to go up and over, and the higher the mountains, the more likely you're to get, snow and glaciers and things like that. But as that water is condensing because the warm air is rising, and as it does, it cools, the water vapor condenses, you get clouds, and then you get rain or snow, and that's falling on the windward side of the mountain range. It's facing the wind. Okay, by the time the air and air mass has moved up over the mountain, it's dried out and it's cooled down quite a bit. It's not able to even hold that much moisture, plus it's already lost most of it. And so it's leaving, going down the other side, what we call the leeward side. It's leaving where from the wind came from, and that creates a rain shadow. So that air, as it comes back down, it's cool and it's more dense, but it's dry, and it also warms up quite quickly as it starts to funnel down the other side of the mountain. So the last one for precipitation is seasonal change in wind patterns. And here we have a winter monsoon and a summer monsoon. You can think of it as a really big example of a land breeze and a sea breeze. Since here in Southeast Asia we have the monsoon season. So here in the winter you have high pressure that is sitting up over the land, high pressure is going to blow air to low pressure, so low pressure is going to be sitting out over the ocean. You have air coming off of the land, which is drier. It goes out over the ocean and then picks up moisture and then is able to come back. However, if you're on the land, you're going to be having a dry season. Then the summer comes, so the low pressure from the south along the equator actually shifts up quite a bit, and the high pressure is now out over the ocean, the low pressure is over the land, and that high pressure is blowing moist, warm air over Southeast Asia. So you're going to get considerable change in precipitation because you have your air masses coming from a warm, humid air mass that formed over the ocean. So significant changes in precipitation. We'll take more look at it in class, and hopefully you can answer those questions from the beginning and get some specifics. Make sure to read the book and answer some of those questions on the quiz after the video. All right, have a good one.